In this video, I want to show you how you can take an existing schema per tenant setup, like we have here, A, B, C, D, 4 identical tenants, and start managing with Atlas using database schema as code. The first thing that we need to do is to create the source of truth schema, basically to go from database to code. And to do this, we can use Atlas schema inspect and local. I have a connection string here to a specific tenant because all tenants have currently an identical schema. I can do this. So I'm inspecting the schema. You can see the output here, but I want to work on a SQL file. So I'm going to do format SQL. Okay, I'm getting the schema as a SQL file and just going to overwrite the schema SQL file. So now I have my schema as code. Just to verify that things are in sync, I'm going to run Atlas schema apply and local. This does the diff between this tenant's schema and the source code here, schema.sql. Because every tenant should have an identical schema, if I do schema apply against tenant B, I should also be. Okay, the next thing I want to do is to generate the baseline migration. I'm going to be using version migrations because I want to have SQL files documenting the specific migration for each version. So I'm going to run Atlas migrate diff and local. I'm going to call this revision baseline because my migration directory does not exist yet. Here we go, and we have our baseline migration. Now if I try to Atlas migrate apply, Atlas will refuse. It's connecting to the database and it sees that there is no revisions table tracking this specific schema, so it doesn't know which version the database is in, and also it sees that the database is dirty, it's not empty. So it stops here, it says, okay, I'm not sure what I do. In this case, what we need to do is to baseline the target database. Okay, and this is how we do this. We add to our configuration a baseline, and we need to copy the version number. So let's see if we have something here. Copy the file name. We don't need this suffix. So now we're telling Atlas that this is the baseline. This is where the database actually is right now. So if we do Atlas migrate apply, again, it will tell us no migration files to execute, but actually something did happen, which is we created the revisions table that is tracking tenant A, what revision it is in now from the perspective of Atlas. And if we see now that before we had only 3 tables, upon refreshing, we'll see the Atlas schema revisions table, and we'll see here that Atlas recorded that this database is now in this version. So up until now, we have shown how to do one tenant, but our challenge really is how to do this for multiple tenants, and for this we have the next section. So after setting up for a single tenant, let's see how schema per tenant works. The feature that we use is something that we call target groups. Now, if we look at the documentation, we see that the main difference between a single and a multi-tenant deployment is that we use the for each meta argument. So if we define our environment configuration, we can explode this single environment into multiple environments. And to do that, we need some list of URLs that represent the different targets, the different tenant schemas. So we can see in this guide that we have multiple strategies that we can use to obtain this list. The very most naive one is just to use an array in our HCL. But we will see that we can do all sorts of things like loading it from an external JSON file adjacent to our configuration. We can load it using an HTTP query from an endpoint. If we have some microservice that has knowledge of the different tenants, we can use this way. What I want to show you is how to use the information schema for Postgres to pull a list of tenants and their URLs using a database query. And let's see what this looks like. Let's walk through this configuration really quickly. So we use the SQL data source to load from Postgres any schema whose name begins with tenant underscore. We move the database URL to a local. This is basically a variable because we are reusing it both for the data block and we're going to be using it in our environment that now has a for each meta argument. So when we run Atlas commands against this local environment, we're actually talking about a group of environments that are defined by the result of this query. Now everything else remains the same, or one thing that is different is that we are now using the URL query set function to set the search path for the URL for each tenant. So this basically becomes the correct database URL for each target tenant. In cases where different tenants reside in different database servers, we would need a bit more elaborate logic here, but perhaps we would just store the connection strings in the database or some microservice that would just give us the list of tenants and their URLs. With this, we should be able to do something like Atlas migrate fly and local. We now see that it went through all 4 target environments, all 4 tenants. Now if we look at the schemas for the different tenants, we should see that indeed each of them has a Atlas schema revisions table, meaning Atlas is tracking each schema. We can verify this with the Atlas migrate status command. So for example, let's see in tenant A, everything is okay. Tenant B is the same, and so on. So after baselining all of our tenant schemas, meaning all of them are now tracked by Atlas, let's see how we can start proactively managing the database schema using Atlas and database schema-as-code. With Atlas, whenever we want to make a change to the schema, we must first change the desired state. So let me just create a new column in this table definition. And beforehand, I went and created a new environment called dev. The reason is that the migrate diff command that I'm about to run cannot run in a multiple environment block. So now, after changing the schema and adding the email to column, I can run Atlas migrate diff and dev. What Atlas does is calculate the diff between my schema file and the migration directory, because there is something to be done here. It has added the email to column. Let's verify by running again, and it will tell us that the migration directory is already in sync. Now that we want to apply this to our multiple target environment, we can run Atlas migrate apply and local. Maybe it's not the best name, but watch what happens next, and you will see that all databases were upgraded. We can now take, for example, tenant C, and let's refresh the schema for the users table, and we will see here our email to column. So this concludes our guide. This is how we take an existing database with a schema per tenant architecture and start managing it with Atlas using database schema as code.